A water tank has a shape of an inverted circular cone with a height of 4 units and a base radius of 2 units. So the tank look like this. We have inverted circular cone. This height equal to 4. This radius equal to 2. Water is pumped into the tank at a constant rate 2. So we know that how fast the water is pumped into the tank. Determine the rate at which the height of the water level is rising. So water is pumped into the tank. The water keep rising. And we need to compute the rate of change for the height, 3 units. So here's a setup. We have this circular cone. So say this is a circular cone. This one has height 4. So the height equal to 4. H equal to 4. Or let's just say 4 here. The radius, the base radius equal to 2. Radius here equal to 2. The water is pumped into that tank. So we have the water here. So we have water pumped into the tank. And the water level keep increasing. And we want to consider the instant where the water up until here. And we need to compute the rate at which the water's level is rising. So let's do that. The water keep pumped into the tank. The volume of this water keep increasing. The height here keep increasing. So let's say we have this height equal to 8. The water is pumped with the rate 2. So this means that dV over dt, this rate is given to us. dV over dt is 2. We need to compute dH over dt at the moment where the height here equal to 3. Now set up the relation between V and H. Relation. The volume of this cone equal to 1 over 3 pi r squared times 8. Pi radius squared times 8. For example, here I have this radius r. When the water is pumped until here, the radius is small, and then it gets bigger and bigger. The radius is bigger, the volume is bigger here. So at the times h equal to 3, we can know what is the radius. Because look at this right triangle. I can draw it in a separate picture. So here's the height of the tank equal to 4. This length is 4. The radius of the base equal to 2. This length is 2. Now we are in this water level right here. This water level. So let's work with this right triangle here. So the water level, say 8. At this level, the radius, this radius equals r. We have the relation. This right triangle is similar to the bigger right triangle. We have radius over 8 equal to the radius of the bigger triangle, 2 over 4. Yeah. So you know that radius over 8 equal to 1/2. So radius is always 1/2 of the height. Radius equal to 1/2 the height. So I can rewrite v as 1 over 3 pi radius 1 over 2 of the height square times the height. This term I rewrite it as h over 2 square. So the volume equal to 1 over 3 pi h square over 4 times 8. V equal to 1 over 12 pi h cube. Now we only need to do the computation with v and h. So we get rid of the radius because we write in terms of the height. V and h are both depend on t. So now we do derivative. Remember that we need to use the chain rule. dv over dt 1 over 12 pi 3 times h square times dh over dt. So we use chain rules there. This one is a derivative of h cube. So the right hand side you have 3 and 3 down there can cancel out. So it's 1 over 4 pi h square dh over dt. And this is dv over dt. dv over dt is given to us. It's a 2. It is a constant rate. It's always equal to pi over 4 h equal to 3. H equal to 3 square dh over dt. So this gives us dh over dt 2 times 4 over 9 pi, which is 8 over 9 times pi. This one is the final answers.